Start. All right, Bismillahirrahmanirrahim. So we are doing the equation of a circle in the last class. Today we will talk about the bisection of chords and some more different points in the equation of circle. Before we have to go forward, we have to revise the things that we have done in the last class. Let's go. Right, in the last class, first of all, we had to talk about the equation of a circle, that is x minus a whole square plus y minus b whole square is equal to r square, where you have a and b is basically the center of a circle and r is the radius. And there is another form. This is the completing square form, and there's another expanded form in which you have to open the square, so you will get the formulate x square plus y square plus 2fx plus 2gy plus c is equal to 0. And after that, we have done different question in which we are going to be write the equation into the standard form. And after writing the equation into the standard form, we have to find the center of the equation and radius. In the same way, we have also learned that if examiner is going to be give you the center and the radius, so from how we are going to be find the equation of a circle. So we have done different questions and different strategies. And one of the most important thing we have got that how we are going to be do the completing square method. For example, if you have any quadratic expression or equation, how you are going to be write into the completing square form. And then we are going to be convert this expression, the equation of a circle that is written in the expanded form. We have converted it into the square form. We have to write the x values together, y values together, and do the completing square. And at the end, we will get the equation of a circle. And from here, we have to find the center of the equation and the radius. These are the things that we have done in the last class. Now, in today's class, we are just going to be talk about the bisection of the chords. Okay, before we have to go for the bisection, we have to talk about the perpendicular bisector. Yes, anyone having the idea what is perpendicular bisector?
We measure the distance using the compass.
Oh, what is
What's the
perpendicular
question?
bisector? What is perpendicular bisector?
Perpendicular bisector is a line that goes through the midpoint of a chord and it's perpendicular, so the gradient is the negative reciprocal.
Yes, perpendicular bisector is basically a line that divides the other line into two equal parts. Look at here. This line, let's say this is the distance A to B and it is C. If this is the midpoint and they are making a 90-degree angle, the red line divides this blue line into two equal parts. So this line is known as the perpendicular bisector. A line that divides the other line into two equal parts, that line is known as perpendicular bisector. Yes, Simon, it is clear?
Yes, sir.
Yes, Ishal, Aisha, Vajay Khurram. Because the next thing is totally dependent upon this concept. Yes, Simon, it is clear. What is perpendicular bisector?
Yes, sir.
Yes, sir.
Yeah, sir.
Yes, sir.
Okay. Now look at here. For example, if you have a circle and there's any chord on it, any chord. Let's say I'm just going to draw the chord here. Let's say this is the chord AB. This is the chord AB. Now, if you have to draw the perpendicular bisector on it, I'm just going to draw the perpendicular bisector on it like this way. So always remember, if you have a chord and you will draw the perpendicular bisector on it, that always passes from the center. Again, if you have any chord on the circle and you will draw the perpendicular bisector on it, that always passes from the center of the circle. For example, if you have any other chord, let's say this is the chord, and you are going to be draw the perpendicular bisector on it, So always remember, it always passes from the center as well. It doesn't matter how long the chord it is, what type of chord it is. The chord can be anywhere on the circle. If you have to draw the perpendicular bisector on it, that always be passes from the center of a circle. Yes, everyone, it is clear.
Yes.
Yes, sir.
So basically, this is we are going to be used if sometimes examiner is going to be give you some points on the circumference, and he says that you have to and you have the coordinates of this one, but that is not diameter, because if it is diameter, you simply take the distance and divide by 2, and if it is center and any point is given, you have to use a distance formula to find the distance, so you will get the radius. But in this case, you have these 2 points and there is another point. So by using that point, you need to find the center. So what you will do, you will find the equation of a line that is perpendicular bisector on AB. You have the find the equation of a perpendicular bisector on it. So from here you will get the equation of a line 1. Here you will get the equation of a line 2. You will simplify them. After solving simultaneously, you will get the center. Yes, sir. The theory is clear.
Sir,
We will
it
do the
should
question.
be 2 lines.
Yes, obviously. If you have this is a chord, so this is a perpendicular bisector line. If this is a chord, this is another line. If you have to
There
make
should
another
be two
chord,
chords, right?
so it
At
can be two
least.
chords, three chords, four chords. Yeah, if you need to find the center, so you need at least two chords.
Okay.
Yes, everyone. Any question till here?
No, sir.
All right. Let's do a question. Now this is in this one, obviously, I'm just assuming that you have a very strong grip on the coordinate geometry as well, okay? So he says that the point A, B, and C lie on the circumference of the circle. So I'm just going to draw the circle. This is a circle. We have a point A. Let's say this is A. This is B. This is C. It is 0, 17. It is 8, 13. It is minus 10, 7. Use the property of the chord and perpendicular bisector to find the equation of a circle. So look at here, I'm just going to cut the chord A to B and B to C. A to B and B to C. Now I'm going to use it to find the center of the circle. All right. Obviously, once we have a center, we can easily find the radius. So what I'm just going to be do it, I'm just going to be draw the perpendicular bisector. So I'm just going to talk about the line AB, and I need to find the equation of a perpendicular bisector. Yes, can anyone tell me what is the relation? What is the relation between these two lines in the gradient if they are perpendicular?
Uh,
The
Negative reciprocal
Yes, they are negative reciprocal of
gradient.
each other. Yes. So we have to find the gradient of line AB. The gradient of line AB, that will be equal to 13 minus 17 divided by 8 minus 0. Yes, that would be equal to, yes, that would be equal to minus 4 over 8. It will be minus 1 over 2, right?
yes,
Okay, so what will be the gradient of the perpendicular bisector of AB? take the negative reciprocal, it will be 2. Okay, we will get the gradient of this line. Now we need to be find any point from where the line is passes from. So look at here, I told you it is a perpendicular bisector, so this means that the line must be passes from the
Center, midpoint.
from the midpoint of AB. So let's we have to find the midpoint of AB. Midpoint of AB. Yes, that will be equal to 8 plus 0
4 and
divided by 2.
15.
4,
4,
Okay,
15.
17 plus 13 over 2. That will be 4 and 15.
15.
15.
So this is the point I'm going to be get 4 comma 15. Now look at here, we have the gradient of the perpendicular bisector, and we have the point where the perpendicular bisector is passes from. So need to define the equation of a line. So what is the formula? We have y minus y1 is equal to m into x minus x1. So y minus 15 is equal to gradient x minus x1, that is 4. So I'm going to be get 2x minus 8. It is minus 15 over the side will be plus 15. So I'm going to get y is equal to 2x plus 7. Yes, sir. Good. It is clear.
Yes, sir.
What it is? It is the equation of bisector on line A, B. Okay, by the same situation, by the same way, we have to be, you can meet BC and draw the perpendicular bisector, or you can make AC, you have to draw the perpendicular bisector. It's your choice. I'm taking BC. Now my focus is you have to be find the equation of the line, perpendicular bisector line on BC. So first of all, what I will do, I'm just going to find the gradient of BC. Now I'm finding the gradient of BC. That will be equal to 7 minus 13. 7 minus 13 divided by minus 10 minus 8. Minus 10 minus 8. Yes, that would
1
be
over
equal to
3. 1 over 3.
positive 1 over 3.
Yes.
Okay, so the gradient of perpendicular bisector of ABC, that will be negative 3. So we are going to get the gradient that will be negative 3. Now, I need to be find the point. So this means that I need to be find this midpoint. So midpoint of this is the line BC, that will be equal to 8 minus 10 minus 10 divided by 2, 13 plus 7 divided by 2. Yes, that will be
Minus
equal
1
to
comma 10.
minus 1 comma
10.
10. Now we will get the gradient. We have the point where the perpendicular bisector is passes from. So let's we have to find the equation of the line. That is y minus y1 is equal to m into x minus x1. Yes, anyone having a question till here? Muhammad Ikram, Vijay Khurram?
No, sir.
Yes, sir.
No, sir.
Yes, Ishal, Aisha?
No, sir.
Sir, I have.
Yes.
Sir, for every single perpendicular bisector we do the negative reciprocal of the thing, yeah?
Yes, because we know that this perpendicular bisector is perpendicular on it. So we are not able to find the gradient directly because we don't have any point. But we know that it is perpendicular. If it is perpendicular, then their gradient and this gradient having a negative reciprocal relation.
Okay.
And why we are doing it? Because we know that the perpendicular bisector will be meet at the center. Okay, let's find the equation. We have y minus y1, that is 10, gradient minus 3, x minus x1. So I'm just going to be get minus 3, x minus minus plus, again minus 3, and plus 10. So I'm just going to get the equation y is equal to minus 3x plus 7. So look at here, I'm just going to be getting another equation of the perpendicular bisector. The property that we have done, if you have to draw the perpendicular bisector of the chord, that always meet at the center. So we have the equation of two perpendicular bisectors. We are going to be solve it simultaneously. All of you till here, you know that how to solve the equation simultaneously. So let's solve it. I'm just going to be give the name equation 1 and equation 2. So comparing equation and equation 2, so you will get 2x plus 7 is equal to minus 3x plus 7. Minus 3x on the other side plus 3x. 7 minus 7. That will be 0. So you will get x is equal to 0. We will get the x coordinate. Need to find the y coordinate. You can substitute this value in any equation. Let's use equation 1. So y is equal to 2 into 0 plus 7. So we'll get y is equal to 7. So we'll get the center 0, comma 7. This is the center of circle 0, comma 7. Yes, everyone. Any question till here? We have done all of these things. We have to be find the equation of a perpendicular bisector on AB. We have to find the perpendicular bisector line on BC. And after getting it, because I know that they will be meet at the center, so I just solve simultaneously. I'm just going to be get the center, that is 0, comma 7. Yes, anyone having a question till here?
No, sir.
Yes.
Yes, Ishal, Aisha, Wajah Khurram,
No, sir.
Ahmed.
No, sir.
No.
Okay, look at here. We will get it. Now what we need? We have a center. I need a radius. For the radius, you can find the distance from these 2 points, or these 2 points, or these 2 points. It's your choice. Let's say find the distance from A and center. Let's I will find it here. We have a distance will be equal to y2 minus y1. So 7 minus 17 whole square plus 0 minus 0 whole square. So it will be 10. So you will get the distance is going to be 10. Distance means it will be the radius. So I'm just going to be get the radius will be equal to 10. So what is the equation we have? X minus a whole square plus y minus b whole square is equal to r square. So x minus a, what is the center we have? 0 plus y minus b, the b value is 7 and the radius is 10 square. So you will get the equation x square plus y minus 7 whole square, 10 square would be 100. So this is the equation of a circle we are going to be get. So look at here, examiner just gives you the 3 points that will be on the circumference, and by using that point, we have find the equation of a circle. Yes, everyone. Any question till here?
No, sir.
No, sir.
No, sir.
All right. Now, now there is another question. He says that the 3 points A, B, C lie on a circle in the diagram. He says that show that AB is a diameter of a circle. Okay, to show that AB is a diameter, you have done one property, the circle theorem in your IGCSE. He says that if you have a circle and there is a diameter, any angle that is subtended from the diameter on the circumference that always be 90 degree, right? This is the property of a circle. If you have to make an angle from the diameter anywhere on the circumference, it can be here, it can be here, it can be here, it can be here, anywhere on the circumference that always be 90 degree. Angle subtended from diameter on circumference is always 90 degree. Yes, I will. It is clear.
Yes, sir.
Now he says that you have to show that AB is the diameter. If AB is the diameter, then this angle must be 90 degree, right? So this means that if you want to be sure that AB is the diameter, we need to be sure that this angle is 90 degree. Yes, you have to go to the trigonometry. Can anyone tell me how we can show that it is 90 degree?
We find the gradients of AC and then CB, and then we multiply the gradients. If the gradients is -1, then it's a right angle.
Yes,
Can
we have
you
the other that way as well. Okay. All right, all right. You're exactly correct. If we have to find the gradient of A to C, that will be equal to the negative reciprocal of the gradient of BC. If this statement is true, so then we can say that they are making a 90 degree. Yes, any other one?
we do the perpendicular bisector between A and C?
So what you will get from there?
Uh, we can prove if it's 90 degree, this one.
If you have to draw the perpendicular bisector here, so how you will prove this angle? We need to be prove this angle, it will be a 90 degree angle.
That
There
it's
is
the we can prove that the center is the same of the bisector.
the center is same, so obviously if you have a center is same, so it does not prove that this angle is 90 degree because this is the angle between the chords.
Yeah.
It is not a bisector. Bisector that divides the line into two equal parts. Okay, the one thing that I will tell you that the gradient of A to C will be equal to the negative reciprocal. This is the one way, and the other way is you have to be use the Pythagoras theorem. Pythagoras theorem is the side that is opposite to 90 degree is hypotenuse. The hypotenuse square is equal to the sum of the square of two other sides. If the both sides will be equal, then this means that it is right angle triangle, otherwise it is not. Right? Because in the only the right angle triangle, the hypotenuse square will be equal to sum of the square of two other sides. Yes, everyone, remember Pythagoras theorem?
Yes, sir.
That is the way, or this is the way. This is easiest. Let's go by this way. Next, we have to find the gradient of AC. That will be equal to 7 minus 14, it is x1, y1, it is x2, y2. So 7 minus 14 divided by 8 minus into minus 9. Yes, everyone, it is clear? Yes, I'm just finding the gradient, everyone.
One
Yes,
sec.
clear.
Yes, sir.
All right, so it will be minus 7 divided by minus 10 minus is plus 8 plus 9, that will be 17. Now, let's we have to find the gradient of BC. So it is minus 10 minus 7, minus 10 minus 7, 1 minus 8. That will be equal to minus 17 divided by minus 7. So this will be cancelled out. You will get 17 over 7. So look at here.
17 over 7, you wrote 13.
Gradient of AC multiplied by the gradient of BC will be equal to minus 1. It is dividing on the side multiply. So look at here. We will get that minus 7 over 17. 17 over 7 is equal to minus 1. So look at here. The answer is equal to minus 1. This means that these lines are making a 90-degree angle. It shows ACB is 90-degree, so AB is the diameter. This is the first question. You have to show that AB is the diameter. So we have shown it. Yes, everyone. Any question till here?
No, sir.
No.
Yes, Sujay Khuram, Mustafa, Ishal,
No, sir.
Aisha.
No, sir.
No, sir.
Ishal and Aisha, are you here?
Yes, sir. Yeah.
All right. Next, he says that you have to find the equation of a circle. Again, we need to find the equation of a circle. So we need the center and we need a radius. So first we have to find the center because it is the diameter. So their midpoint it will be the center. The midpoint of AB must be the center of the circle. So let's say you have to find the midpoint of AB. That would be equal to minus 9 plus 1 divided by 2. Minus 9 plus 1 divided by 2. 14 minus 10 divided by 2. And that is basically your center. So it will be equal to minus 8 over 2, that will be 4. And 4 over 2, it will be 2. So we'll
2.
get the center will be minus 4 comma 2. Now, what is the second thing that we need? We need a
Radius?
radius. For the radius, you have to take the distance from center to C, center to A, or center to B. It's your choice. So let's find the distance. The distance will be equal to, I'm just finding the distance from center to C. This distance. So 7 minus 2 whole square, distance formula, plus 8 minus 4 8 minus into minus 4 whole square. Yes, sir. You would read out in the distance formula.
No, sir.
No,
No,
sir.
sir.
Right. Go back here. So I'm going to be get the distance is equal to 7 minus 2, it will be 5 square. Minus the minus is plus 8 plus 4, it will be 12 square. So it will be 25 plus 144. That is 169. So that will be equal to 13. And that is our radius. So now we are going to be get the center and we have the radius. So the equation of a line will be x minus x1. So it will become plus 4 whole square plus y minus 2 whole square is equal to r square. So that will be 13 square. You have to simplify them. It will become 169. Yes, everyone, it is clear. Examiner is going to be give you the diameter. So while using the diameter, you have to find the equation of a straight line. Yes, everyone. Any question till here?
No, sir.
No, sir.
No, sir.
No.
All right. Okay, there is another circle theorem. Theorem is, for example, if you have a circle and there is any tangent line on it. Yes, can anyone tell me what is a tangent line? Yes, anyone knows what is tangent?
A line passing and touching the circumference of the circle.
Yes, a line that touches the circle at single point. Okay, if it is passes from like this way, it is not a tangent. A line that touches a circle at single point, that line is known as tangent. And if it is the radius, always remember the angle between the radius and the tangent, if they meet at the same point, that always be 90 degree. The angle between radius and tangent is always 90 degree if they meet at same point. Same point, obviously, for example, if the radius is given, obviously there is no relation between this tangent and this radius. So they must be meet at the same point. So the angle between the tangent and the radius that always be 90 degree. Yes, everyone. Any question till here?
No, sir.
No, sir.
All right, let's do the question. How this property help us to find the equation of a circle, or with the help of equation of a circle, how we can find the equation of tangent. All right. He says that the circle C has an equation x minus 5 whole square plus y minus 2 whole square is equal to 25. The point P, that is 2 comma 6, lies on C. Find the equation of of the tangent at C. So this is a circle. Let's say this is the tangent. This is the point P, that is 2 comma 6. And this is the equation of circle. We will get the center, that is 5 comma 2. Now we need to be find the equation of the tangent. Okay, we have the point that is on the tangent line, but we don't have the gradient of this one. So how we can find the gradient of the tangent line? Anyone? How we can find the gradient of the tangent line?
We find the negative reciprocal of the radius.
Yes, because we can find the gradient of the radius, right? Because we have the center, we have this point, we can easily find the gradient. And this gradient is basically the negative reciprocal of the tangent line. So I'm just going to be give the name O. So I'm just going to be finding the gradient of OP. That would be equal to 6 minus 2 divided by 5 minus 2. Y2 minus Y1 divided by X2 minus X1. So 6 minus 2, 2 minus 6 minus 2, 2 minus 5. That 2 minus 5. So that will be 3 divided by minus 3. So it will be, sorry, 4 divided by minus 3. Now, this is the gradient of the radius. Now let's we have to find the gradient of tangent. That will be negative reciprocal of the radius. So it is minus 4 over 3. So it will become plus 3 over 4. Yes, Sagwan, it is clear?
Yes, sir.
Yes, Fajay Khurram, Ishal, Aisha, Ahmed, Anush.
Yeah.
Yes, sir.
What we have to do, we have to find the gradient of the radius. That will become 4 over minus 3 because they are perpendicular. According to the property of the circle theorem, they are perpendicular. So we have to take the negative reciprocal. So we will get the gradient of the tangent line. So now look at here, we have the gradient of the tangent line and we have the point P where the line is passes from. So we have to use the formula y minus y1 is equal to m into x minus x1 to find the equation. So y minus y1 is 6, gradient is 3 over 4, x minus x1 is 2. 3 over 4, x minus 2 times 2 is 4, so it is 3 over 2. It is minus 6, on the other side plus 6. 3 over 4, x. Yes, minus 3 over 2 plus 6, that will be equal to 2 times 6 is 12. 12 minus 3 is plus 9 over 2. Yes, please check them. It is minus 9 over 2 plus 9 over 2.
Yes, sir.
sir.
9/2.
So look at here. This is the equation of tangent line at P2, 6. So look at here, in today's class, we are just going to discuss the different cases. Okay. In all the rest of the questions, the worksheet I'm just going to be give you. In all this worksheet, you have these type of questions. Sometimes you need to be use the property of some circle theorems, the property, the angle between the tangent and the radius, and one of the most important property that most of the students are going to be forgot, and that is difficult for you because it is not difficult one, it is just lengthy. So that is the angle if you have to draw the perpendicular bisector of the chords that always we meet at the center.